Hello everyone, today I will introduce the problem. Egg job with 2 eggs and n floors. You are given 2 identical eggs and you have to assess a building with n floors left from 1 to n. You know that there exists a floor f where 0 is less normal than f and f is normal than n. Such that any egg dropped at a floor higher than F will be break, and any egg dropped at or below floor F will not break. In each move, you may take an unbreak egg and drop it from any floor. If the egg breaks, you can no longer use it. However, if the egg doesn't break, you may reuse it in the future moves. Return the minimum number of moves you need to determine with a certain what of the value f is. So let's see an example. If there are 1 x and floor n is, for example, 4 floors. How many moves we need to do is we need 4 moves because we need to move from the first floor, check whether it is break. If it is break, we can return floor 1. We can return the first floor, and if not break, we check the second floor, the third floor until the fourth floor. We need at least 4 moves. And what about 1x with 5 floor? I think it is the same. We need 5 moves. So what about 2x? If we have 2x and 2 floor, we have 2 choices. Check from the first floor or from the second floor. If we check from the first floor, we use 1 egg. If it break, we can just return the first floor. We found it, or else we need to use this egg because it doesn't break. So we can reuse this egg. We use it and to check the rest floor. The rest floor is the second floor, so we no need to track 1 floor here. We can use a DP here. Use DP. Let's write here DPIZ, where I presents the x and J represents the left of the floor. We check from the first floor, there use 1x, and if they don't, the egg is break, we don't need to check anymore. We just use 0 as 0 here, or else it doesn't break, we use this egg. So the egg remaining is 2, and to check the remaining floor is the second floor, so it is only 1 floor here. And then we check, if we check from the second floor, we do the same thing. If it is break, we need to check the first floor, so we remaining 1 egg and 1 floor here. And if it is not break, we don't do anything, return 0. So the minimum moves we need, this is 1 here because there's only 1 more here. So the minimum move is the minimum of these two actions. Okay. So this minimum of these two. And what about 2x 3 floors? We need to track first floor, second floor, and the third floor. And we check the first floor. If it is break, we return 0, and if it is not break, we remaining 2x and 2 floor to track. And we try to check the second floor. If it is break. If we start from the second floor, if it is break, we need to check with 1 egg and 1 floor. We need to check the first floor. Now it's not break, we have 2 eggs and the remaining is the third floor, so only 1 floor to check. And if we start from the third floor, if it is break, we need to check the first and the second floor, and it is not break, I don't need to check 0 here. So, and then we return the minimum of these 3 solutions. So the dpij here is if the x is larger than the floor, we don't need this too many x, so the dpij equals to dpi minus 1j, or else I think we get the minimum. We need to get the minimum from the max dp. If the x is break, we only remaining is I minus 1x and j and k k minus 1 floor. Now the egg doesn't break, we remaining is j minus k floors, where k is 1, so k and minus j. Okay, so this is the dp function here, and in this problem there are only 2 x, so we can define the dp right here, and when there are only 1 egg, the minimum moles is so when there are only 1 x here, the minimum moles is equal to the floors, so dp0j is equal to j. And when there are 2 eggs and with 1 floor, we only need 1 moles here. And then we iterate the floor from 2 to n, and update the dp1j here, because this means there are 2 eggs here, and we define a minimum parameter to calculate the minimum moles here. Iterate k from 1 to j and update the minimum value. Use whether it is the egg is break or the egg isn't break, and update the dp1j here. Then we return dp1n.